What is up, guys? We're going to be taking a look at this lab, Insufficient Workflow Validation. So often when we're making use of a web app, sometimes there's functionality that requires a series of steps, and those steps need to be in the correct order. So a simple example, in the case of a web app that offers a shop, we would expect the user to first add an item to the cart, then visit the checkout, then make payment, and only after the payment is received should the item actually be dispatched to the customer. That workflow has to happen in the appropriate order. It doesn't make sense if a user is making payment before they've added items to the cart, and it certainly doesn't make sense that an item would be dispatched to the user physically before they've made payment for said item. This lab is going to be an example of that, which is why the title is Insufficient Workflow Validation. And as we're going to see, there is some validation in place, but it's definitely insufficient. Now, we're logged in with the default user-supplied credentials, Wiener, Peter. We're at the home page of the shop. We do have $100 in store credit by default. I have spent some of that so far. We're going to add whatever this product is to the cart. We are going to make a purchase using the remaining store credit. You can see 97.41 in store credit, and in the background we're going to be capturing these HTTP requests with Burp Proxy. We choose place order. Your order is on the way. So 3 steps there: add item to cart, make payment. Step 3 is then the physical dispatch of the item to the user. So we can see the flow of HTTP requests in Burp Proxy. So we have the initial GET request to the cart. The web app then sends a POST request to cart checkout. So we're actually making payment at this stage. And after that, we make a GET request to cart order confirmation. You can see we have a query string there, order confirmed equals true. Let's focus on that request, something that should only happen after the checkout stage is complete. Let's send that to the repeater in Burp. Let's resubmit that to the back end. Check out this response: you have not checked out. In other words, this is an example of workflow validation. Okay, the user wants us to dispatch the item. Has the user actually checked out? No, you've not checked out. This workflow is incorrect. We can't proceed from this point onwards. However, it turns out that the back end is not really checking to see if the user has made any payment. Actually, all the check is doing here is seeing if there are any items in the cart. So we send the POST request to cart checkout, payment is taken, and then in response to this GET request, the web app checks the contents of the cart, makes the assumption that payment has been completed, it then clears the cart and dispatches physically the items to the user. So in this case, when we visit get cart order confirmation, order confirmed equals true, the web app assumes that we've already made payment. It then looks into the cart to see which items we've just purchased, and it sees the cart is empty. So at this stage, there's a problem because presumably payment has been taken, but it's unclear to the app which items have actually been purchased because the cart is empty. We therefore get this error message: you have not checked out. Hopefully you're beginning to see the flaw in the logic here. There's an assumption that payment has been made purely because we find ourselves at /cart/ order confirmation with the query string order confirmed equals true. So there's no explicit check for payment, it's all assumed at this stage. And the faulty logic is, why else would a user be here if they hadn't made payment? Of course, the problem is we can very easily just force browse to this location by entering it into our browser, or even sending another HTTP request with the repeater. So if all the app is checking for here is to see which items are in the cart, then all we actually have to do is re-add the items to the cart and then resubmit this GET request. Now, the objective of the lab is to purchase the lightweight elite leather jacket. We don't have enough in store credit to cover that, but let's just add it to our cart and then resubmit this GET request with order confirmed equals true. Get a different response this time. Lightweight elite leather jacket, your order is on its way. Now, we can't for certain say the implications of this particular bug, because it might be the case that after we receive this message, maybe a second check is actually made offline by a human to make sure payment has gone through before the item is dispatched. So it's possible that the user might get an email in a couple of days saying there was a problem with your purchase, we couldn't take payment, etc. We don't know. Even if that's the case, it's still a bug. We shouldn't be receiving this message on the front end telling us our order is on its way. That's the most benign iteration of this. What we're probably intended to believe here is that this item has been dispatched. It tells us your order is on its way. In other words, we've just purchased a very expensive item without paying any money, and it's because there was insufficient workflow validation. The app assumed, purely because we had that GET request, order confirmed equals true, that payment had already been made and there were no explicit checks to make sure payment had been received. So worst case scenario is this is a very severe, potentially business destroying vulnerability in the web app. Key mitigations here from a development perspective is just to start off with the default assumption that end users may visit routes randomly. Don't assume that they won't visit a certain GET request just because the app doesn't provide them with the address until later in the process. An end user can at any point force browse to a specific URL, in other words, copy and paste it into their browser, or they can tamper with a HTTP requests using burp. So make the assumption that what if user tries to visit this order confirmation page before they've placed an order? What happens then? So if you code and test your web app with that idea in mind, you'll be able to mitigate against these types of insufficient workflow validation problems. Alright, that's pretty much it for this lab. Thanks for checking out the content, and I'll catch you guys in the next lab.